Hello, today I'd like to show you Hammond Power Solutions Energy Efficiency Calculator. First, we're going to go to www.hammondpowersolutions.com, and from there we're going to go to the Resources section and select the Toolbox. Once I go to the Toolbox, we're going to select the Energy Transformer Savings Analyzer and go visit the site. And once I go to the HPS Transformer Savings Analyzer, I'll need to fill in some base information. First of all, I need to fill in the contact information. In this case, it's John Doe from ABC Electric, and he is working at the Innie Saint Hospital project on a transformer retrofit. We need some information down below here, and we're looking at a couple main pieces of data. First of all, we're asked what year the existing transformer manufacturer is manufactured at. And what we're really looking at here is, was it manufactured before 2007? Because in 2007, the Department of Energy required all transformers to meet what we call the TP1 energy efficiency standards. Before 2007, none of the transformers had to meet any energy efficiency standards. So that happened in 2007, and in 2016, they increased the energy efficiency standards once again. And what happens now is that the modern DOE 2016 transformers are roughly about 50% more efficient than anything built before 2007. We just want to verify it's built in the USA, in this case from the state of Wisconsin. And in this case, we're also going to use the analyzer's default efficiency levels. While you can go and try to determine the efficiency levels of an installed transformer, none of the information is available on the nameplate or from the manufacturer for units built before 2007, and it's very difficult to actually get accurate efficiency levels when you're measuring a transformer in the field. So in this case, we're just going to use the analyzer's default values. Now I'm going to proceed to step number 2. And in step number 2, we're going to look at the transformers. Now, you could add 15 different transformers if you like, but to make this easy, we're just going to look at one transformer, which is 75 kVA. And again, in an ideal world, I would know precisely what the load factors are for those transformers. You know, it operates X number of hours per day, 5 days a week or 7 days a week. In this case, I don't quite know that, and we're just going to use Hammond Power Solutions Commercial 3 model, which is basically models a medical center that's used 7 days a week. Next, we have to enter some other data, which is basically the cost of electricity. This information can be gotten right from a customer's electric bills, but in this case, again, we're just going to use the default. And we have all of the average cost per kilowatt hours for each state programmed into this. So we know that for the state of Wisconsin, the average cost per kilowatt hour is 10.9 cents. We're also going to look at a demand charge of $10 per kilowatt per month. We're going to say that the AC system performance is 1 kilowatt per ton. And basically what this means is that as the transformer adds heat into a building, then that means the cooling system oftentimes has to remove the heat. Now, this can vary. You know, the state of Wisconsin, the cooling may not be a big issue for the winter months, but it can be a big issue for the summer months. Other places, like, let's say, the American Southwest, the AC system might be on 24/7 for the most part. The other thing we're going to factor in here is an energy escalation cost of 3% per year. So from here, I just go and hit calculate, and I get all of my results. And basically, our goal here is to give you a report that you can actually take and submit and give this to a customer for evaluation. So in this case, we're saying that the main one, 75 kVA transformer based on the application profile of Commercial 3. And again, you can put your own profile in here if you want, but in this case, we're just going to use the pre-built one, is going to save approximately 4,638 kilowatt hours per year. It's going to have about a 0.55 kilowatt demand reduction, and it's going to save approximately $715 in its first year. We also give 5 and 25-year energy savings calculations. Now, these are going to be higher than just taking the $715 and multiplying it by 5, because we are also factoring in the fact that the money you save can be invested, and the assumption we use is you can make 6% interest every year on it. And we're also going to assume that the energy escalates at 3%, which is what we programmed in earlier. So in this case, we're saying after 5 years, using standard accounting procedures, you could probably realize a savings of $4,265, and after 25 years, over $50,000. The net result is that I have a simple payback of 3.59 years and a total project cost of $25.65 based on the cost of the transformer and approximately 4 hours of installation time at $100 per hour for an electrician. Now, there are some things that can change this. Sometimes the electricians may take longer or shorter to install a transformer. Sometimes there are utility rebates that will lower the price. In other cases, you may also be able to get some scrap value for the old transformer that would also lower the project prices. We go through here and we do put a lot of the information that we have in here so everybody kind of understands how we calculate and how we arrived at these answers. We do go look, and you can, if people are looking at what are the benefits of switching, the EPA does have a pretty good location that we reference. And now I get down to here and I have a couple options. I can print the document and I can hand that to somebody. I can save it as an XML file. Basically, this is a data file. Saving it as an XML file is important because if I save it, I can now go back a day, a week, a month later, and I can upload this file without having to re-enter all the data. So I'm saving the data for this file for this program to upload. We do not save the data for security reasons. So whatever you put in here when you leave the site is gone. I can save this report as a PDF, which will then allow me to email the report to somebody. And finally, I can go here and hit contact me, which basically will request somebody from Hammond to contact you to answer questions or maybe work on the project with you. And the last thing here is we do have some of the calculation assumptions. So again, we're not trying to hide anything. If you're wondering how we derived at our numbers, this is a lot of the information we have right here. If you have any questions, we'd be happy to work with you in the future and look forward to new projects. Thank you very much.